Welcome, everyone. So most of my career over the last 25 years or so has been in digital design, web management, this broad area of the internet. I started working in the internet back around 1994, and a lot of the focus became around user experience and customer experience and usability and issues like that. And I felt that the core learnings were to you are not your user, and to think beyond yourself and think beyond the organization seemed to be the philosophy that was emerging to the world of the user and user centric or customer centric design. And I felt for most of the time, 20 years or so, that this was the universe. And then, of course, with the emerging climate crisis, I began to wonder, is there something else beyond this other than making it easier for the user? And I realized, well, there's a society out there as well, and there's an art that we're on, and that we don't just think about the user experience, but we also need to think about the earth experience. And the more I thought about the earth experience from a digital point of view, the more disturbing things became. The more I began to discover that there's a very, very dark side to digital, that digital is indeed physical, although most of us think it is invisible, and that if we truly want to understand the dark side of digital, we need to understand the devices, because it is in the devices that most of the damage to our ecosystem occurs in relation to the digital world. So basically, this is digital recycling. This is a picture of digital recycling. The vast majority of digital products, whether they are smartphones or laptops or TVs, are not recycled. And those that quote unquote are recycled, a lot of them are recycled like this. Us in the rich world, the global north, Ireland or Norway or North America or the UK, we use our digital products, and then we often surreptitiously export them to poor countries where they are recycled in open pits and burned to try and extract some copper or some precious metals from them, because digital materials contain a lot of precious materials. A typical smartphone contains about 1,000 materials. So globally, in 2019, we were producing about 54 million tons of e-waste. That dipped a little bit during the pandemic, not in the global north, in the poorer countries. Poor people could afford to buy less electronics during the pandemic, so it's slightly less in 2020, but the estimates are that it's going to boomerang back or bounce back, and we're going to have huge growth. And in essence, it's doubling every 15 years. So we're creating vast quantities of digital waste. We rarely recycle in any way properly, and most products are designed so that they cannot be recycled. Many people working in the informal economies to recycle these wastes are children and women. Children as young as 5 years old, because their hands are small and they can pick out the small pieces of copper from the actual devices and stuff like that. And of course, the poison leaches into the soil. That smoke is highly toxic. So there's huge health issues connected with this. But of course, it's not our problem in the rich countries. Just it's the poor people who have to deal with our problem that we create. Digital materials are incredibly resource intensive for manufacture. They're both energy intensive and resource intensive, and they are part of the reason we are on an extraction mania around the world. Around 1900, we were extracting about 7 gigatons. By 1970, it was 30. By 2000, it was 60. By 2020, it's 90. And by 2050, it's estimated it'll grow to 170 gigatons. This is not sustainable. Forget about CO2. Our extractive mania is not sustainable. We will destroy the world 1,000 other ways than just through global warming. So raw material use, according to OECD, is expected to double by 2060. An electric vehicle requires 4 times the minerals of traditional vehicles. So yes, electric vehicles, we should have electric vehicles. They are more efficient than traditional vehicles. But just having lots of electric vehicles, if we changed everything to electric vehicles, well, that would be the end of the earth tomorrow, because the earth could not deal with that resource intensity. What we need far more than electric vehicles is walking and cycling. We need to consume a lot less. Renewable technologies will not save the world in their creation. If we create them at volume, we will in fact destroy the world even faster. Here's the world of digital. A vintage car is something at least from the 80s, the 70s, the 50s, the 40s. A vintage computer is from 2015. Apple announced this laptop, which was made and released in 2015, is now vintage. In other words, no more support, no more backup, etc. So the digital world, the Apples and etc. and the Samsungs design for waste. They design products that will become waste within 2, 3, 4, 5 years. Nothing gets to 10 years old in the digital world. So we have a world of digital where very, very little recycling goes on, and where we have very, very short life cycles, and where we have huge intensity in the materials needed to create these digital products. That is a dark underside of digital that rarely gets talked about. So using a typical smartphone on a yearly basis, and this depends on the electrical grade and the renewability and the grade, how much CO2 is being created. But typically, it's somewhere between about 3 and 6 kg of CO2. So using a smartphone for about 12 months will create something like 5 kgs of CO2 for a typical user. So that's a fair bit now. That's the weight of 2 reasonable size laptops. It's not an insignificant quantity of CO2 that we're pumping into the atmosphere using our smartphones. However, that is just a small part of the story. Manufacturing this smartphone takes about 60 kg, creates about 60 kg of CO2. Probably another 100 kg of other materials need to be dug up to actually get the materials that go into this tiny little 150 gram smartphone. So the vast majority, certainly in consumer electronics, is in the actual manufacture. So if you're going to take anything out of this presentation, it is hold on to your digital devices as long as possible, get them repaired, choose devices that have the longest possible life. Digital creates a tremendous amount of damage during the manufacturing process, and very few are really aware of the damage that digital is doing. So global smartphones sales about 122 million in 2007, and growing and growing and growing to about 1.5 billion a year by 2021. So basically, it's estimated that since 2007, we have manufactured about 15 billion smartphones. 15 billion smartphones. So at an average of 60 kg of CO2 per manufactured smartphone, that's 900 million tons of CO2 just in the manufacture of these smartphones. PC sales, went up and went down because of the smartphones, but still quite substantial, 230, 209, 261. But a typical laptop or a desktop creates about 300 kg of CO2, so much more intense for the laptop or the desktop. So that's about 4.2 billion PCs sold since 2006, 300 kg CO2 to manufacture. That's 1.3 billion tons of CO2 for our PCs. These numbers are not small numbers, and they're just a tiny part of the digital manufacturing ecosystem. The lives of machines. Some organization did a study on how long should a specific set of machines last in order that they are at least somehow sustainable from a materials extraction point of view. So a vacuum cleaner was estimated that it should last for about 11 years. And what it's actually lasting for is about 6.5 years. So it should last for about 11 years. In 2011, a washing machine, 17 years. It was lasting for 10 years on average, but it should be lasting for 7 years. So, of course, the 2021 washing machine is much more efficient. It's talking to the internet and all that sort of stuff. Once you add digital to an environment, its lifespan is severely impacted. So now the typical washing machine has an average life of 6.3 years. Whereas, of course, it should be lasting about 17 years. So as soon as digital comes into the equation, the lifetime drops. And we're, of course, extracting more resources and using more resources, and we're in a very, very vicious cycle. A laptop should be lasting about 20 years, and of course is only lasting about 4.5 years because of planned obsolescence and the way laptops are made, etc., in the process. So that's a bit the device, but what is driving the explosion in devices is data growth. In 2010, it was estimated there were 2 zettabytes in existence of data. I think by 2013, somebody did a study in 2013, and they said more data had been created in 2013 than in all of previous history. Basically, in an 18-month period around 2013, more data created than in all of previous history. So a zettabyte of data is almost unimaginable. I calculated how many trees you would have to cut down to print out 1 zettabyte of data. And I calculated that you'd need to cut down 20 trillion trees to print out 1 zettabyte of data, 20 trillion trees. Now, there's only about 3.5 trillion trees on the planet, so that's impossible, right? But that's just to give you some sense of what a zettabyte is. 2015, 12, 33, 47, by 2035, it's estimated over 2,000 zettabytes of data. These are unmanageable, unbelievable quantities of actual data. 28% annual growth rate, it's exponential, and 90% of it is crap. 90% of the data we create, we don't use 3 months after we've created it. So most of data centers are digital landfills. We are creating massive quantities of data that we don't even use. And we need all these devices, etc., to create digital rubbish, digital crap, digital trash. Everywhere you can see it in web page size, going from 400 kilobytes to 4 megabytes from 2005 to 2020. You can do an awful lot to design a page with 400 kilobytes. You really don't need more than 400 kilobytes. Why do we have 4 megabytes? Because we're lazy design, don't even try and optimize, etc., in the process. Everything is exploding. Storage, taking some actionable points. I'm going to finish with actions. We're going to take, they say the cloud is greener. And sometimes, yes, it is because of utilization. We can't really go into the dynamics of cloud versus on-premises. But as a general rule, if you were to store something on a local drive, and it created 1 gram of pollution in that storage. Cloud storage would be about 10 times greater. Cloud cold storage, which is what is archival storage. But hot storage could be up to 3,000 times more intense in its always on, always availability type. So if at a basic mechanical level, storing something that has to go the shortest distance uses less energy and creates less waste. There are a lot of complexities, but in a lot of situations, the cheapest and the most environmentally friendly thing for you to do is to store your stuff on a local drive rather than to store it in the cloud. Just looking at energy intensities in relation to communication devices, in relation to running video means. That's partly why I don't use video on these presentations. How old-fashioned is that? An analog audio on your traditional phone, that old, stupid, ancient that nobody would be found dead with, making a call on type of phone. Having an hour length of a call on that creates about 3.6 megabytes of data. So two people on an old analog phone, you remember those indestructible phones that lasted for 40 years in a home, right? About 3.6 megabyte of data. If you had the same audio call using Zoom or Skype, that would be about 27 megabytes. So 8 times more pollution, 8 times more data, making that call over the internet than making that over. That's progress. Of course, it's progress. We all know it's progress. And of course, if we go for standard video, it's 270 megabytes. If we go for high definition, it's 540. If we try to be really snazzy and use 4K video, well, that's 9 gigabytes. And if we use 8K video, which nobody can see anyway, that's 36 gigabytes. Isn't it wonderful? We can destroy the planet and be really cool while doing it in the process. Transferring data, right? Wired, it seems counterintuitive, but using a wire, if you're transferring significant quantities of data, is far more energy efficient than going through. It's about, well, certainly twice as energy efficient as going through Wi-Fi. Once you start going up into the Gs, there's all sorts of debates, but it's much, much more energy intensive to transfer over the Gs than it is to transfer over wire. So if you're transferring and you're doing a lot of work at home, plug in a wire as I plug my a wire in. It's faster, it's more reliable, it's more secure, and it's more environmentally friendly. And definitely the next option is Wi-Fi, and only go to the Gs when you actually absolutely have to. So here, I don't expect you to understand this slide, but I'm just asking you to have a little bit of faith in me for these metrics. I'm sure I've made mistakes on them in some ways, but I asked a lot of people over the months, you know, how many hours to create a typical 1,000-word piece of content? And the consensus came back, yeah, about 20 hours for the idea, to write it, to edit it, to get sign off, to publish it, etc. So I assume that all of this is happening on laptops. These 20 hours, the discussions are happening on laptops. That this document weighs 5 megabytes. There's maybe 5 or 10 images in it, or whatever. And that if it's read just once, and that read time takes 4 minutes, well then, how much CO2 is created? So basically, I looked at 4 components: the creation process, the distribution, so sending it to that one person in somewhere or putting it in a way that they can access, the amount of time, the 4 minutes that it took them to read it, and then it gets stored someplace for maybe another person to read it. So basically, what we can see is that 99% of the energy or the waste is in the actual creation process, not in the distribution, not in the storage, and not in the reading, because only one person is reading it. So that I estimated, based on a whole bunch of background analysis, creates about 2 kgs of CO2, or the equivalent of 0.2 of a tree. A typical tree, as I'll explain later, can sequester about 10 kgs of CO2 a year. So this gives you a sense for us understanding what is happening in digital. It's, you know, it has an impact from the devices, from the energy, etc., and trying to somehow calculate that. So the same 1,000 words, 20 hours, etc., weighs 5 megabytes. If it's read by 10,000 people instead of one person, then most of the waste moves to the reading. 96% to the actual reading is taken up, because it's 4 minutes on 10,000 people's devices. in the process. So in the use of the thing. So when you've got a big environment with a lot of use, most of the energy intensity is in your user's environment. And you need to be thinking about that from a design point of view. So that's 80 kgs of CO2 or 8 trees in the process. But which is better or worse? One person at 2 kgs, who reads it, or 10,000 people at 80 kgs, which is 8 gram per person. So maybe it's much better the 10,000, because if it's a good document and it's helping them, be more environmentally friendly or do something positive where they save energy, then it's been effective. And if only one person reads it, it's created 2 kgs. So basically, the per capita, just one person is 250 times more intense. I just want you to start thinking about these ideas, just thinking about the impact that content has, the impact that digital has. It has a carbon footprint. It has, when we create those documents, when we create those PowerPoints, when we create those images, they are not invisible to the earth. They actually do have an impact, every single one of them, on the earth. And this was here, Mozilla, the people who create the Firefox browser, when they did their analysis, their CO2 analysis, they saw 2% of the impact was in their offices, in their engineers, in their programmers, in their designers, in their documentation, etc. But 98% of their footprint was in the use of their browser. So often, and that's thinking beyond our environment out into the user and out into the earth. We need to think in layers in calculating costs these days, whereas we calculate costs often and impacts on a very, very narrow basis. This is the first photograph, or supposedly certainly one of the first photographs that was ever taken. It was in 1826 or 1827 it was actually taken. By 1900, there was about 1 million photographs, and by 1900, we were taking about 1 million photographs a year. And here's what has happened to photographs over the years. It was fairly quiet up until the 70s and 80s and 90s, but something happened in the 90s and it really began to explode. So right now, or last year, we had taken about 13 trillion photos. So we went from 1 million in 1900 in total to about 13 trillion. So half of the photos taken since 1900 were taken between 2015 and 2020. In fact, in 2020, we took 1.4 trillion photos. We took more photos in 2020 than in the entire 20th century. And are we looking at those photos? No, we've taken so many photos, we can't look at them anymore because there's just too many of them. So the photo resolution, so this is relative. If the resolution was at 1x, it would be 1 megabyte, right? This square. The weight of this dimension would be 1 megabyte. If it was 2x, it would go up to 4 megabytes. So this is as a resolution. If it was 3x, so after 2x, most people can't see it, certainly on a smartphone or a laptop. So it's pointless. 3x and 4x are pointless exercises in destroying the planet for ego and vanity and coolness. 4x, it's 16 megabytes per image, and 8x, it's 64 megabytes. So not alone are we taking vastly more photos, but with the modern devices, their weight intensity is greater. And the heavier it is, the more negative impact it has on the environment. Just give you an idea of videos. So 720 HD, 30 frames per second is 40 megabytes for 1 minute of video. Right? As we go up to 1080, it's 60 megabytes. 4K is 135. 4K with 30 frames per second, 170. And 4K 60 frames per second, 400 megabytes. Just 1 minute. Just 1 minute of video. Potentially 400 megabytes of actually data for that 1 minute of video. Photos stored in the cloud by 2020 estimated about 8 trillion. And by 2022, about 10 trillion photos. 10 trillion photos. it's almost unimaginable. 10 trillion photos. So doing my calculations about trees, with trees being able to sequester about 10 kgs of CO2. So I did calculate that taking photos from 2000 to 2020, you need to plant 80 million trees. Assuming an average of 15 seconds to take each photo, transferring them about 50 million trees, transferring them up to just once, up to the cloud, viewing them. I estimated you'd only view half of them once, about 40 million trees, and storing them, because you're storing them year after year, because we never delete anything. We never get rid of anything in digital. We're constantly building up and storing 515 million trees would be required to be planted just for our photo addiction of the vast majority of photos that are poor quality and will never be looked at again. Looking at email, something we do a lot of. So basically, sending a traditional letter by post was calculated at about 29 grams of CO2, the total CO2 for the paper, etc., and transport, on average about 27 grams. A HTML email, and this is why I differentiate between the two, HTML, because it is more coding, more intensity, and often a HTML email also contains a version of itself as a text email. So HTML email estimate about 6 grams, a text email about 2 grams, average email about 4 grams in the process. So HTML email about 6 grams, text email about 2 grams, spam 0.3 of a gram, because most spam gets caught server side. It doesn't transfer too broadly around the network. It gets caught early on. So spam tends to have a lower CO2 impact per spam. But an attachment, those typical attachments are at least half a megabyte, and some of them much, much higher. Somebody did a study and it says, well, an email with an attachment can be 50 grams, right? 50 grams impact of CO2. I'd love to hear other people if you've got different numbers on this or like to challenge it. Okay, so 405 billion letters are posted every year. 405 billion standard letters are posted every year. 390 billion emails are sent every day. 405 billion letters posted every year, 390 billion emails sent every single day, right? 84% of emails are spam, right? 84% of emails are spam. So let's have a look at this in a total quantity on a yearly basis. So letters, 405 billion, emails, HTML emails, 8.5 trillion, text email. So I'm estimating that we're sending roughly the same equivalent of HTML as text emails. So 8.5 trillion HTML, 8.5 trillion text, attachments, emails with attachments, about 5.4 trillion emails with attachments, which is 24% of emails contain attachments. That's how I got that number. And spam is 120 trillion. So 120 trillion spam are being sent every year, right? Translate that into CO2, tons of CO2, right? Letters, about 11 million tons, almost 12 million tons of CO2 is caused by sending letters every year. HTML emails, 51 million tons. Text emails, 17 million tons. Emails with attachments, 269 million tons. It's crazy. You know, please challenge the numbers. Spam, 35 million tons of CO2. Right? These are enormous numbers, right? Here's an interesting thing. There's a link between the quality of an internet and the number of attachments. One of the reasons there's so many attachments floating around is because the vast majority of organizations will not invest in a good information architecture for their internal information. And as a result, people feel they need to send lots of attachments. So if you've got lots of attachments going around your organization, it's generally a symptom of very poor information organization practices within your organization. So the amount of trees for to deal with letters, 1.2 billion for the physical letters. For email, letter HTML email, 5 billion. For text emails, 1.7 billion. For attachments, 26 billion trees would need to be planted every year to deal with emails containing attachments. And spam, 3.6 billion trees. These are crazy numbers. Please challenge me on them. These are crazy numbers. And this is a study we did with one organization a number of years ago. We call this a top task study. We asked a bunch of managers, very large organizations, what are the activities that are most time consuming to you? And we see here there's, the bunch of activities, about 70 activities, but 2 activities get as much of the vote as the bottom 45 in the environment. What are those 2 activities? The top task has as many votes as the bottom 34. What could the top task be that's most time consuming? It's emails. And the number 2 is the decision-making process. So these were management tasks, management-type tasks in an environment. Then we asked them a variant, the exact same list, but we asked them, what are the activities that add most value to you? Still 2 at the top, 2 as much of the vote as the bottom 45. The top 2 tasks are decision-making process and team management. So the top task as much of the vote as the bottom 34, and emails was 30th. So it was out in those tiny tasks in the environment. So email was number 1, the most time consuming, but way out there as the most valuable thing for you. So let's have a look at the value and the behaviors of dealing with email. And email per se, it's obviously more than the device or the way of email. So the average, in 100 hours of work, a typical worker spends 28 hours reading or dealing with emails. But for every 100 emails that a typical worker gets, there are 35 of them that are unread. That just don't, they've either been CC'd or they don't look on them, right? And here's the thing about attachments. For every 100 attachments, people that receive attachments, 94 of those attachments are unopened. 94 out of 100 attachments are unopened. People don't open them, they don't look at them. So let's look at pure waste here. Let's look at pure waste. So unread text emails, what's the impact on trees? You need to plant 600 emails to deal with unread text emails. You need to plant 1.8 billion trees to deal with unread HTML emails. You need to plant 3.6 billion trees to deal with spam. And you need to plant 25 billion trees to deal with the emails with unopened attachments. So 31 billion trees need to be planted every year to offset the pollution caused by unopened attachments, unread emails, and spam. What extraordinary waste. What an extraordinarily wasteful environment digital is, right? How do we take action? What do we do, right? So here's some digital waste reduction principles. Identify the true cost. We need to think much more deeply about these issues. The environmental cost, the cost to the user of that attachment that they're not even going to look at, etc. in the process. Embrace a crazy concept like degrowth. And I'll explain that, what I think that means in this digital context. And visualize. One of the reasons we create so much waste in digital is because it's invisible. We need to start visualizing the impact of digital, because its impact is real, but we don't see it, so it doesn't exist. So thinking beyond you, the organization, the user, the society, the art of our decisions in digital. What is the impact? What are the broader impacts that, the true costs and the true value that is actually occurring by launching that subsite, by publishing that extra page? If there's only one or two people looking at it and it costs 2 kgs to create it, the World Bank, I saw a study a number of years ago, 35% of their PDFs were never downloaded. Why do we create all this content that nobody is looking at, and all the waste that goes into the creation of that content? Calculate the true cost, the cost to make, the cost to use, the cost to maintain, the end of life costs. Maintaining the page, taking down and archiving the page. Remember earlier I showed you that it can be hundreds of times cheaper to archive something in a digital environment than to have it immediately available in what's called a hot, immediately available environment. So embrace degrowth, consume less emails, consume less content, consume less of everything. We cannot get out of the climate crisis with the same strategies that got us into it. We have to consume less of everything, and that means taking and consuming and creating less. Creating less photos that we're never going to look at anyway. So looking at the creation process and cutting it and saying, hey, we don't really need this document. Let's bring back the editor. Where's the editor gone who used to stop all the crap even seeing the light of day, or at least a lot of it? So in relation to data, organize. The more time we spend organizing data, the less time we have to create crap data. Basically, the more organization, the more classification, the more information architecture is generally a signifier of a quality approach rather than a quantity approach. We reuse more, whether it is old images or whatever, but of course we can't reuse those old images if we haven't put proper metadata on them, because we can't find them. We share more. We create stuff in a way that is shareable, whether it's content or code or whatever. We archive what is no longer currently useful, the benefits of archiving. And we delete 90%, because in most of the time, in digital, 90% of it is not useful anymore. In our devices, we maintain our devices. We hold on to them. We create the longest life possible for them. So some tips here, some specific tips. Running online meetings, waste reduction tips. Video to greet, then go to audio. 90% less pollution, 90% less waste in the environment. Audio, an audio call for an hour, 27 megabytes. A video call with two people, 270 megabytes. So, and why do audio is great. We survived with audio calls for many years. Why does everything, but it's better than flying. Yeah, but it's not as good as audio, in the process. Use the lowest resolution possible, smallest screen possible. I used to have a huge, big screen. Now I work everything off my laptop. Just if we could do these small changes but scale them, we could make a real difference. Don't save meetings unless essential. Delete saved videos after this, after 3 months. This presentation is being saved, but the previous 5 I did not save. Roughly every 6 months, I save one. But really think about saving and what should be saved. Delete saved videos after 3 months if they're not being used. Don't attend meetings unless it's genuinely important. Right. So in behaviors of buying devices, buy a laptop, not a desktop. The lowest spec, best energy ratings. Keep it as long as possible. Look at the warranty and repairability. Don't use large screens. Reduce monitor brightness. Do not use screensavers. Monitor off after 5 minutes. Sleep after 10 minutes maximum. Shut down when not using. And make sure, and definitely shut down at night, and switch off everything at night that you can switch off. It's estimated in the US 20% of typical energy bill is from vampire power. power from devices that are not being used but are on. So we're destroying the planet just to have stuff on that we're not even using. And hold on to our devices as long as possible. In relation to our smartphones, minimize notifications. It'll reduce energy. Disable location services. They're very energy intense when you're not using them. Remove unused apps because they're constantly calling back. So if you're not using them, remove them. Reduces energy. And all of this saves on your battery so your phone will last longer, etc. in the process. These are tiny little things that add to your battery life. Think hard before downloading any apps. Watch out for greedy apps. There's certain apps that are much more intense than others, such as Facebook and WhatsApp. Try and keep the battery level between 50 and 80%. Will help the life of the battery. Short charges tend to be better. Don't leave it plugged in at full charge because it's losing a bit of charge and then it's been charged again. So it's not a good activity for a phone. Don't drain your battery completely. If you can, use a wire to charge. Wire charging is 47% more energy efficient than Wi-Fi charging. Remove when charged, plug out the charger, dim the screen, use dark mode for OLED screens. It doesn't use for every screen. Stream in standard definition. Don't expose your phone to a lot of heat. It affects the life of the battery. And the overall rule, hold on to. So this will be available for viewing, and I will make the presentation available as well. I know I went through a lot of stuff really fast there. So an average tree absorbs about 10 kg of CO2 per year. So this is the visualized digit. So I tried to visualize it in trees. And then I went to another level and I said, well, one tree, let's imagine one tree on average has 10,000 leaves. Now, trees have all sorts of different quantity of leaves, but just for simplicity purposes, let's say a tree has 10,000 leaves. That means one leaf equals 1 gram of CO2 if an average tree is sequestering 10 grams of 10 kg of CO2 per year. Right. So I'll be coming back to that in a moment as well. But specifically looking at email waste reduction, I talked about. So calculate the cost of sending and receiving the emails, and deciding not to send, etc. Read less, unsubscribe, reduce the notifications. Don't check so often. Create less emails. So use less text when you're writing and sending back, cut those long strings, cut that out, that long text out that nobody needs to see. Avoid HTML, use text email. Send as a default as a text. Why do you need HTML? Don't have a look at your signatures, and particularly don't have images in your signatures, and be really, really careful about attachments. Use links instead in the process to the document or whatever. Organize the intranet, and that'll reduce attachments and stuff like that. Maintain more. Allocate time to organize your emails. Delete all emails more than 2 years old. Archive the older stuff and store it locally. You don't need to store it in the cloud, and you're never going to look back over that anyway. Delete emails with large attachments and file sizes immediately, and delete old accounts in the process. So a HTML email, think about it this way. Every time you send HTML emails, you kill 6 leaves. Or 6 leaves need to grow to deal with the carbon, the 6 grams of carbon that HTML email has caused. That email, 6 grams of carbon. If you sent a text email, it's just 2 leaves. It's just 2 leaves. And if you send no email, it's no leaves. Thank you very much.